program, right? So then, the Turing test would be, I tricked you thinking that you thought I was a real human being, but actually I was an AI.
The Turing Test, proposed by the British mathematician and logician Alan Turing in 1950, is a...
Hey, someone's got their AI working in the background. Good. So basically it's a test. And the judge is evaluating, the human being is evaluating whether the human thinks that whatever is presented is another human being or an AI. Now, you pass the Turing test if the AI can fool you to thinking that, in fact, it was a human being, right? So have you guys ever read an article and you're like, oh, I can't tell if this is an AI or if this is an actual writer? We're seeing more and more content produced by AI. I'm sure you've seen some videos. At some point, maybe movies will be made, fully in AI, and taking some of your sort of feedback from, how you're responding to it, right? We're not there yet, but just keep in mind that whatever AI we experience now is going to be the worst AI you've ever experienced in your life. So it's only going to get better. The first AI program, logic, were by, a logic theorist, Newell and Simmons. Note the date, 1955, 1950s. Dartmouth Conference, that's where they had their first term AI, 1956. That's where they used AI, and it became a established sort of academic discipline. And it's actually very interesting. This is an example of some code or a program that was trying to fool people into thinking that, Eliza was actually a human being. And you can read a couple of the interactions. I don't know if anyone ever remembers interacting, but basically it says, is something troubling you, ? And you say, men are all alike. And then Elijah says, what is the connection, do you suppose? So it's just asking you these open-ended questions, right? So most of the times people could say, oh, that's not really, that's a computer, right? Or that's an AI. That's not really a human being. But some people were fooled. There was a few, right? This was based on a rule-based system and symbolic reasoning. This was sort of launched in 1966, right? Which is actually very interesting. Now we interact with ChatGPT and it's much more fluid. And to an extent, it can actually help us think of new ideas, right? So in the AI industry, there's been 2 winters. I don't know if you guys know what a winter is, but we're actually experiencing a winter right now at Johns Hopkins. Can you guys tell me what kind of winter we're having? Do you know how much funding has been cut from Johns Hopkins?
Government funding, yeah. Good.
What's the magnitude?
386 million, 400, something like that.
Yeah, it's hundreds of millions of dollars, right? Some people say 800, some people say 400. What happens is that whenever professors usually have labs and they hire graduate students and postdocs and they, focus in on a particular area. And how do they get funding? Well, they have to write for grants and NIH or whatever it may be. And, right now, because of the way that government is sort of contracting and becoming more efficient, a lot of this funding is cut off. Right. So, we could argue that some of our colleagues and friends, unfortunately, in Bloomberg's public health and also maybe in SAIS, anything sort of international is getting cut. That's like a winter, meaning that there's no funding to continue to do the research. Right. So AI has experienced 2 of those such winters where there wasn't a lot of funding that was coming out. So it's very difficult to continue to do the research. Right. Okay. So, in the past, in the 50s and 60s, they were kind of known as expert systems, and they focus on solving a specific, well-defined problem. Okay, and then now we move to the 1980s and 90s. When I was a graduate student at Columbia, the neural network structure was well known and it was available. And we'll cover this in depth a little bit later, but just sort of understanding that we started to shift from these rule-based systems into something that has a lot of data going in. And then we had to sort of figure out and, sort of adjust these dials, these parameters or weights so that they could sort of fit the data, right? However, even in the 1980s and 90s, we had another AI winter where it was difficult to find funding for some of this research project. Few of the people, sort of stuck to their guns, meaning like George Hinton, right, the grandfather of AI. So even, riding out these winters, he would continue to sort of research, which was important, right? At that time, this backpropagation is probably new to most of you guys. But basically, in this class, we're going to learn a little bit about backpropagation, but more try to get the intuition out. You'll see the math in the whatever it is, but it has to do with the chain rule, and it has to do with understanding how to update, how to turn these knobs in order for this neural net to fit the data better, let's say. So backpropagation is a particular technique that was it was known, but it was applied, I think, by Hinton in the early days to solve this neural network problem, basically adjusting weights so that the neural network can make better predictions, okay? And this was like still the early days of neural networks. We are in the stage where we use transformers, right? So ChatGPT, those are the ones based on transformers. A transformer is based on a lot of neural networks, and you'll see a neural network is kind of based on a perceptron. We'll cover a little bit of the perceptron today. And the perceptron is the way you create that has to do with adding and multiplying and taking one activation function. So we'll go through that a little bit today. But, I want to concentrate on giving you guys the building blocks so that you can see how everything is put together, and then you feel comfortable putting these things together. But this class will be more based on the intuition and based on sort of, trying to solve real world business problems with these tools, right? So I want to give you tools, and I want to give you a problem, and I want you to give it a shot, and I'll give you a little bit of guidance, right? Okay, so now we move on to modern AI. This is sort of 2000, 2010. During this time, we had a lot of data coming out from the internet, as you guys know. We also had advances in computing. These are the GPUs from NVIDIA, right? And also cloud computing. Then we had a couple of really interesting deep learning breakthroughs. Now, not surprisingly, a lot of these breakthroughs happened because we got some data that was labeled pictures. And now we challenge other, graduate departments and other schools. Hey, can you come up with a better model to make predictions? These are cats. These are dogs. What do you see on the internet? Do you see pictures of cats and pictures of people's faces? And so we were challenging each other. And, competition in the ivory tower is always very, very exciting to get, graduate students on board. And they're coming up with creative ways to structure these neural networks to make predictions. And then, the convolutional neural network was kind of, fine-tuned to the point where now we can use it to recognize quite a bit of, objects and animals and people and so forth, right? So you could argue that Fei out of Stanford created just a database of pictures and labels, and that was a significant contribution because we needed some kind of place, like something that's a safe place for us to compete and figure out if this model is getting better, if this is a real innovation, right? So that was actually very nice. Okay, and now we're seeing the transition from academic research to the industry. That happens it's very fluid on the West Coast. You have Berkeley, you have Stanford, you have Silicon Valley, you have Capital, you have repeat entrepreneurs in the tech space. We probably see that pretty often at MIT/Harvard. We're seeing that more and more, I think, down at, here at Hopkins and, Baltimore and also DC. But, to an extent, I think we are still not as fluid as, say, some of the other places out there. But, that's changing quite a bit, due to a large part of you guys here and, people taking this stuff that you're learning in practice in school and turning it into practice and into companies. Okay, so this is just the glimmer, this is the transformer. We're not going to really get into that today, but we will sort of dissect it and understand some of these pieces. There's, data that goes in, stuff happens, and then it makes sort of a prediction at the end. Now, very basically, what's happening here, you'll hear this story a couple of times, is that we've taken all the data that has ever been sort of produced by human beings, including books that were written before the internet. And we've got all that data and we put it into a model. And the model has sort of captured a lot of the relationships in this data. The relationships may be complex, they may be nonlinear, and so basically now a model, a large language model that we'll talk about in a second, we can interact with that now. Some people will say this is a compression of information, right? Other people may interpret it as sort of something that is borrowing bits and pieces. How do you know what to pay attention to? How do you know the context of how to predict the next word? But basically, this transformer structure is predicting the next token. The next token is like a subword. So you have all these words before, it's trying to make a next prediction of its token, and it's doing a pretty good job. And that structure has unleashed all this ChatGPT and all this, other things that we'll see a little bit later on and throughout this class. Word embeddings were sort of published and invented in 2013. This basically says that a sentence can be broken down into words. Words can be broken down into tokens. Tokens can be broken down into a vector. Now, once you map a token into a vector, now all the linear algebra stuff starts coming to play. What are some of the tools in linear algebra? How do you take a vector and check if it's correlated or related to another vector? So is this word correlated to that word, or is this word is cosine similar to that word, right? What if you have a vector and you want to project it into a higher dimensional space than the dimensions it has? Or many times, let's take a vector and let's project it into a lower dimensional space, right? So, these are some of the concepts that are going to be used. This is not a linear algebra class, so we're probably not going to do too much there, but the tools that you need to do this is linear algebra and a little bit of calculus, and then some coding. Okay, and then sequence to sequence, recurrent neural networks, attention mechanism. Attention mechanism is in predicting the next word, what should we pay attention to before it? What words should we pay attention to? In a sense, my intuition is that these words or tokens have become these vector of numerical vectors. And, for finance people, numerical vectors could be daily returns or weekly returns of stocks. And this attention mechanism is basically a correlation matrix of stocks, but instead of stocks versus stocks, it's words versus words, or tokens versus tokens. So what are highly correlated, what are not highly correlated in that sense? Okay, and the attention mechanism is actually very, very important. So given a particular word, what are the words surrounding it? What should you pay attention to, right? And so that's where that's coming into play. All right, let's look. You guys will see this transformer architecture many times. I may put in some videos that explain it a little bit more for those who are technically inclined, but note that we will not program or walk through all the details of this architecture. I'll give you guys intuition, but we're not going to do any kind of computation. We're just going to use this, right? Okay. So one question for you guys is the current progress of AI. Many advances are due to neural networks. How old are neural networks? We know it started in the 1940s and 50s, right? We've seen some breakthroughs. What were the three necessary forces that had to come together to really get us to that next level? What do you think the forces were? What three things came together? I call it the trifecta had to come together.
The internet?
The internet, good, but what did the internet give us?
Like a large amount of access to data, or access to a large amount of data, maybe?
Absolutely. So data was one of them. This explosion in data, thanks to the internet, spam, not spam, and email, click that, A/B testing, right? How do we optimize clicking? We have lots of data. People can post up their books and they can write their blogs. So we have one of the forces is this tsunami of data. Good. What's another force?
Communication, speed of communication.
Okay, so you could say maybe argue the technology got better, maybe the hardware got better, the CPUs got better. Clearly the bandwidth, we had 28.8 or something like that. Now it's like T1 lines and so forth. Now we can even have videos on the internet, right? Which is great on Wi-Fi. So you could argue that there's some hardware aspect of it. So it's the data, it's hardware like GPUs. You think of NVIDIA, think of all the infrastructure companies, right? And then the final one is the algorithms. So by and large, the algorithms, the transformer algorithm, the architectural structure is well known. There's really not a lot proprietary there, but people keep playing with the algorithms to try to come up with better algorithms. So it's a combination of the data, the hardware, and the algorithms or models. So all three have been advancing quite rapidly, and we'll see in a little bit later, these are the scaling laws. And by these scaling laws, you can almost predict how much more advanced we can get in some of these avenues, and you'll see some of the implications there. And then you'll understand why the internet companies or the tech companies on the West Coast are doing what they're doing.
Professor, really quick.
Sure.
So it was access to data, to technological improvements, and what was the third one?
The algorithms and the models.
Okay.
We'll show you. So it's data, the tsunami of data. The next one is a hardware. So think GPUs, think NVIDIA or AMD, right? Because we need something to run these things really fast and faster. And then the final one is the models and the algorithms. This is actually the code, right? So we've had a couple of innovations when it comes to, using neural networks in a, transformer way, where the transformer is basically a neural network and attention mechanism sort of put together, amongst other things. But basically, there's a lot of innovations going on, even in the structure of the algorithms, right? And I'll show you a little bit, give you a little bit of insight into that. And we'll get into the weeds a little bit, but don't get overwhelmed. Most of the stuff has already been coded, and you just have to switch or add one line of code to put in more nodes, or switch from the atom to something else for the optimization. You'll see that it's becoming easier and easier for everyone here. Now, this is a course description. I'm a finance guy, so if you guys want to do healthcare, there's a Professor Gordon Gao who's really good at that. I encourage you guys to maybe take AI Business Essentials from him, because he's going to do more healthcare. I'm going to do sort of more of the things that I know, right? I'm introducing vibe coding because I think it's interesting, and I think that's where the puck is going for you guys. So I'm trying to allow you to have those tools, at least not be afraid of using those tools, and have some kind of intuition on when it could be useful and when you shouldn't use it. So what are the limitations, right? Okay, in this course, expect a heavy workload. How does that make you feel?
Stress. Makes me feel like I'm going to be using AI as much as I can to manage the workload.
What's really funny? When you're a student and some professor says, expect a heavy workload, you're like, oh man, that sucks. But when you're a professor and you say, expect a heavy workload, you're all excited. It depends on where you are. It's the same words. This workload, do your best, all right? Try your best, do your best. Sometimes you need to see some concepts a couple of times. Sometimes you need to struggle with it. And then after a couple of days, you're like, oh, that's how it works. Okay. So don't give up on us. Don't worry. It's okay. The work I give you guys is the same work I'm giving the other two classes. Exactly the same. I'm not going to hold anything back. You do the best that you can, and you manage your time as well. You guys have to manage that. But it's gonna be work. It's okay, right? I'm trying to give you guys, I think, the best assignments that will help you understand the concepts and also increase your skills to what I think will be helpful for you. Okay, I'm not always right, by the way, too. Okay, so I put that into ChatGPT to summarize. I think ChatGPT and these LLMs are great at summarizing things. So, AI is everywhere. It's in every industry. What are you going to learn in this class? Neural networks, deep learning. You'll see what deep learning is. It's nothing fancy. It's just having 2 or more hidden layers, and you'll learn about what that is. We'll do some convolutional neural networks, which is computer vision. We'll do a lot of NLP. This is natural language processing. This has, whenever you're interacting with ChatGPT, that's what you're using, the natural language processing. I think we'll cover more on the generative AI and also the agentic workflow. And we'll point out sort of, some tips along the way, okay? We're going to do vibe coding. Probably every one of your assignment has a vibe coding component of it. Basically, what that means is you're going to interact with prompts using your words, and you're going to get the computer and the LLM to write the code, execute the code, debug the code for you, and generate things for you, right? And you're going to have to adjust it. I like this. I don't like that. This looks good. This doesn't look good, okay? So that's something I think is new, and hopefully you haven't seen before in your other classes. But I'm pretty sure that this will become more and more mainstream in MBA classes, because MBA students are really good at identifying the problem, communicating the problem, understanding the business. Now at your fingertips, you'll be able to code it up and create some apps. So that's going to give you guys a really nice tool in your toolkit. Okay, so this is me, the instructor bio. If you guys have not reached out, LinkedIn to me, say hello. Always looking to make more friends, especially you smart Johns Hopkins students. If you see anybody that I'm connected to that you want to reach out to, by all means, I will send you through. Probably more important on this page is your TA. Actually, your TA is not Mohammed, it's actually Andrew Park, but you can probably contact Mohammed. He'll answer some questions for you. I run a company called SoCat, named after my 2 daughters, Sophie and Catherine, and that's all we do is AI and machine learning, and we